Good morning, students. Now we are going to start module 4, and the first topic in module 4 is data clustering. So we'll be looking at mainly algorithm for data clustering. So before that, let us see what clustering is. So what is clustering? Clustering is the process of dividing data points or the input data into a number of groups such that the data points in the same group are more similar when compared to the data points in the other groups. To put it in a very simple manner, the aim of clustering is to segregate the data into groups. For example, suppose that a shopkeeper or a supermarket owner wants to learn the preference of his customers. It's not possible for him to look into the details of every customer and devise a separate plan for each of the customer. It is quite a very difficult process. So what he can do is, he can take his database, classify the data into say 10 or 11 groups such that in each group the customers have some similar purchasing pattern. Then he can devise some common business strategy for each group. That is one possible way. So it is during these times that clustering algorithms come into importance. Now, like we said before, clustering is the classification of objects into different groups, or it is a partitioning of data into clusters or subsets in such a way that each of the subset will share some common characteristics or common traits. And this common trait is usually measured based on some distance measure. Now, we can say some important points regarding clustering. Please see here the first point. Clustering is dividing the data points into homogeneous classes or clusters. What do you mean by homogeneous? It means similar classes. It means that clustering is dividing the data points into similar classes. Now, what is the second peculiarity of clustering? The data points in the same group are as similar as possible. It will be almost similar to each other as possible with respect to some trait. Now, what is the third important point regarding clustering? The points in different group are as dissimilar as possible. Now, what is the fourth point? When we are given with a collection of objects, we put the objects into different clusters or groups based on similarity. Now we have understood what basically is clustering. Now, what are the applications of clustering? Clustering can be useful in marketing, like we said before, finding groups of customers with similar behavior. It can be used in biology, where it can be used for classification of plants and animals given their features. It can be used for book ordering in libraries. It can be used for identifying groups of motor insurance policy holders in case of insurance industry. And it can be used for city planning, for categorizing houses based on house type, geographical locations, and so on. Now, what are clustering algorithms? A clustering algorithm actually tries to analyze the natural groups of data based on some similarity. So what it does is, each group of data will be having a centroid. Look here, centroid. So each group of data will be having some center point or centroid. It will locate that. The clustering algorithm tries to locate the centroid of each group. And then what it does? Distance of each data point from the centroid of the cluster will be measured. This is what actually a clustering algorithm does. Here you can see some clustering being done. You have say data points. The intrinsic grouping or the inherent grouping in the data is being found, and this data has been categorized into two clusters here. So here I have written the goal of clustering is to determine the intrinsic grouping in a set of unlabeled data. So what do you mean by this unlabeled data? So unlabeled data is written here, the data set whose output is defined as labeled data, and the output, if it is not defined, it is unlabeled data. So usually in supervised learning you use labeled data set because input data set is provided with an output data set or target data set. But in unsupervised learning you just provide the unlabeled data or just the input data set or the data points. So there are different types of clustering. The first is exclusive clustering. So here each of the item belongs to only one cluster. For example, see the orange data points here. It belongs to cluster 0. Blue ones. All these data points belong to cluster 1 alone. And this purple color, it belongs to cluster 2 alone. So if you take the case of one data point, it belongs to either cluster 0 or cluster 1 or cluster 2. It cannot be a member of two clusters. So one of the important clustering algorithms, K-means clustering. Look here, K means clustering. See where the cursor is moving? K means clustering is a type of exclusive clustering. Now, what is overlapping clustering? Overlapping clustering is the one in which a data point can be a member of more than one cluster. It's something like fuzzy. What happens in fuzzy sets? Each of the member can be a member of different fuzzy sets. Similarly, here each data point can be a member of either cluster 2 or cluster 3, something like that. So there is an important algorithm called fuzzy C-means clustering. It is based on this overlapping clustering. Now there's one more type of clustering called hierarchical clustering. Here the clusters are not formed in a single step, but it is formed in a series of steps like tree forming process. You have already seen how a decision tree is formed. So hierarchical clustering is the one in which the clusters are formed in a series of partitions to come up with the final cluster. Now we'll go to what is K-means clustering. K-means clustering is an important algorithm, and this is the one which you will be going to deal with in this module in clustering algorithms. So suppose that a hospital care wants to open a series of emergency care wards. So first what they want to see is they want to find the maximum accident prone areas in the region. So here you can see this one, this green, reds, blues, all are accident prone areas which are found. Now the hospital wants to start emergency units, but for each of the accident prone area an emergency unit cannot be found. So what can be done is you decide the number of emergency care units and then locate it properly. So here you have decided to form 3 emergency care units. So you have to place it properly so that each of this accident prone area can easily access the nearest emergency unit. So in such cases, K-means clustering comes to rescue. So this is an overview of how a K-means clustering algorithm can be useful. So what is the meaning of this K? K means the number of clusters. For example, this is partitioning of a data set into 3 clusters. K is equal to 3. K is equal to 3 just means that it has 3 clusters. Now, what is actually K-means clustering? K-means clustering is an algorithm to cluster n objects or n data points based on some features or attributes into K classes or K partitions. So we are assuming that the input data or the object forms a input vector space. So what it does is actually this. See this formula. This algorithm tries to minimize this equation. And what is the meaning of this equation? This equation means that if we are provided with n data points, we are going to cluster into k subsets in such a way that the sum of squares criterion is minimized. So here I told you we are going to find a geometric centroid for each of the cluster. For example, you have 3 clusters S1, S2, S3. You are going to find 3 centroids mu1, mu2, mu3. And you will find the distance of each of the data point x1 to xn from each of the centroids and calculate the distance and take the square. So that is what is exactly being done here. So our aim is to minimize the sum of squares. So this equation will be, please try to learn this equation. This will be more clear when you go to the example. So the distance of the data points from the centroid will be calculated and that distance will be tend to be minimized. So the clustering of data points will be in such a manner so as to minimize the distance between the data points and the centroids. That is the meaning or essence of this equation. Try to understand that concept now. This equation will be clear once you go to the example. So, K-means clustering is an algorithm to classify or group the data based on some features into K clusters or groups. K is usually a positive integer number. So, what the grouping does is it minimizes the sum of squares. It minimizes the sum of squares of the distances between the data and the clustering centroid. That is the meaning of that equation. So, what are common distance measures used? So, in order to calculate the distance between 2 data points, for example, a data point and a centroid, what do you have to do? You have 2 data points. Centroid is also a data point and you have another data point. So if you want to find the distance between 2 data points, there are various distance measures that can be used. For example, Euclidean distance, Manhattan distance, maximum norm, inner product, Hamming distance and so on. So we'll mainly look at Euclidean distance and Manhattan distance. So what is Euclidean distance? So let x be the vector corresponding to one of the data points and y be the vector corresponding to the second data point. So assume that the 2 data points have m dimension each. For example, x is equal to 1, 3, y is equal to 5, 7. It's an example of 2 data points with 2 dimensions. M is equal to 2. So this 1 is one dimension and 3 is another dimension. For this data point, 5 is the first dimension, 7 is the second dimension. Two-dimensional. Now, what are the common distance measures used? In Euclidean distance itself, you have 1 norm distance, 2 norm distance, p norm distance, infinity norm distance. So what you do is, you calculate the absolute value between the data points. Here, you calculate the square of the absolute distance and take the root. Here, you calculate the pth, the absolute distance raised to p, and take the pth root. You can study these equations. It was asked for university questions. Now, what is the exact meaning of these equations? It can be understood through one example which is provided in the next slide. So let us go to that. See, I've just made an example for your understanding. If you want to calculate the 1 norm distance, this is the equation. X and Y are the data points. I've represented that as vectors. Now, what is the meaning of this? I told you m is two-dimensional here, so it is actually x1 minus y1 absolute value plus absolute value of x2 minus y2. So it can be calculated this way: 1, this 1 minus this 5. The first dimensions I am subtracting. For this data point, I will take the first dimension. For this data point, I will take the first dimension. Now, for this data point, I will take this second dimension. And for this data point, I'll take the second dimension. That is what I have done here. I've calculated the distance. Now, another one is Manhattan distance. So, it is actually same as 1 norm distance, Euclidean 1 norm distance. So, what they say is, if you have a city with many buildings, like in Manhattan, you actually, what you do is the car or some vehicle move through the buildings instead of going around the city like this. So usually the shortest distance between any 2 points will be the hypotenuse. Rather than going this way, you take the hypotenuse. So that is actually Manhattan distance, or it is actually the same as Euclidean 1 norm distance. So K-means clustering is one of the simplest algorithms which uses unsupervised learning to classify the data into clusters. K means a number of clusters, and you will be provided with a data set x1 to xm. So your task is, you are provided with this data, you have to divide it into number of clusters. So the main question is, what should be the number of clusters, optimal number of clusters? If you have a data, whether you need to choose k is equal to 2 or 3 or 4, what is the rationale or reason behind the choosing of clusters? So one method of choosing the clusters is to use the elbow method. So here what you do is, you take the data set and then you run the k-means clustering algorithm. First, say for k is equal to 1, you choose just one cluster and run the clustering algorithm. Then you find the sum of squares. That is our function, right? We have to minimize the sum of squares. So you run the algorithm, you calculate the sum of squares. Then you take k is equal to 2. Run the algorithm, find the sum of squares. Then you do it for, say, k is equal to 1 to 10. You plot the graph between k and the sum of squares. You will get a graph like this, and elbow point is this point, the knee point. The k corresponding to that will be the optimal number of clusters. This is one method to choose the number of clusters. Otherwise, it can be, choosing the clusters of k can be purpose based. For example, if you want to market t-shirts of different sizes. So if you have just 3 sizes, S, M and L, there will be just 3 clusters. Now, if your aim is to provide more comfort with more sizes, you will go for XS, S, M, L, XL. Then you will be dividing the data set into 5 clusters. It's depending on the purpose, application based. If an application demands 5 clusters, choose k is equal to 5. If an application demands k is equal to 3, choose 3 clusters. So here we have got an overview of what is clustering and what is k-means clustering. We'll go to the detailed algorithm with example in the next lecture. Thank you.